So we'll see how it goes. So it's considered section 5.4. And actually half of this you've already done before. But you probably didn't really know why we did it. But anyway, here we go. We're going to talk about, if you look on the calculator, and I just happen to have a calculator here, you see these buttons right here, you see log, log, and we've used that before, haven't we? All right. Remember that change of base theorem that we did? We used that right there. Now, you probably had no idea why you used it or anything, but I'll kind of give you a general idea of how we did this. And then you see this ln. What in the world is that ln right there? You're probably wondering. Okay, maybe not, but it is a logarithm, all right? So this is a logarithm, log, that kind of makes sense that it would be, right, because the word log, all right? And then ln is also a logarithm as well, all right? So let's go and let's just kind of talk about it. So if I had log, you know, we've had all kinds of different bases, and we've worked with, and we've changed it from logarithmic form to exponential form and the other way and all that kind of stuff. But every once in a while, you might have a log base 10 of some number. I'm just going to... And it's not just a random number. It's a number that works out real nice, okay? Let's say we did log base 10 of 1,000. And we try to figure out what that's equal to. So we just said it's equal to x. Let's say we want to do this without using a calculator. So we're not going to do the change of base theorem on this one. We're just going to do this without a calculator. Is that all right? So what would we do? Just had a quiz on it. What would we do? Change it from logarithmic form to exponential. So how would you set that thing up? Is it x to the 10? How about 10 to the x, right, because that's the base. That goes as the base. So 10 to the x, remember, this is the exponent. Logarithms are what? They're exponents. It's just another way to write an exponent. So it's 10 to the x power equals the number, which is 1,000. And now the beginning of that quiz, you had to get the bases to be the same. Remember that? And you set the exponents equal to each other. So I picked 1,000 because this works out real nice and easy. It's just not just some random number, all right? So it's 1,000. How can I write 1,000 so that it has a base of 10? 10 to the third, right? 10 cubed is 1,000. Now look, 10 to the x equals 10 to the third. The bases are the same, so what do we do with the exponents? We set them equal to each other, and x is 3. If you wanted, and I'll show you in a second something, but watch, if you wanted to do this on the calculator, use that change of base theorem, which we kind of skipped ahead just a little bit, had reasons for that, but let's just see if this works on the calculator. Remember how to do this on the change of base theorem? Log of what? 1,000. So we just hit the log button, then we hit 1,000, and then we divide it by... I don't know whether to say bless you or what. What do you say when somebody hiccups? I don't know. There should be something you say, right? Anyway, so what is it? Log what? 10. All right, let's see what happens. So log 10, and we close that parentheses, equals, check it out. That's a 3, just like we said it was, right? We did it without a calculator. Aren't you impressed with yourself? Okay, that you can do this without a calculator? Yeah. I can tell how impressed you are. So that's log, but what was the base? Okay, I did a particular base here. It's what? It's log base 10. Now check this out. I can do this even easier. I went through this whole change of base theorem. Log of 1,000 divided by log 10. But watch this. I can just hit log, just hit the log button, and I can just hit 1,000. 2, 3. And then watch what happens. Equals, boom, same thing. What happened to this log base, log 10 thing? So what must log 10 really be equal to then? So 1. Let me show you something again. So watch, log base 10 of 10. And that equals, we don't know, okay? Now we do because we just talked about that. But let's say it's equal to x. Do the same exact thing. How can we write this? 10 to the x equals 10. Or 10 to the what? First. So x equals 1. So what's log base 10 of 10? It's just a 1, isn't it? All right, so that's kind of interesting to see. Now, what we do, this log base 10 right here, it shows up so many times. It's so common in our life, really, it is. Think about our number system. What is our number system based on? How many digits? How many digits in our number system? 10, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's 10 digits, correct? So everything that we've done is based on tens. All right, this is a base 10. It's so common. We're so used to it. In fact, they call this thing a common logarithm. Now, I'm not really sure that's why they call it, because it shows up so much and it's so common in our life, but that's what I say anyway. All right, there could be another reason for it, but that's how, it makes sense to me though, doesn't it? Base 10 is very common, right? We see it all the time, so they call it a common logarithm. Common has several different definitions. I'm not sure if that's the one they use for this or not. I just make that up, so it kind of makes sense, I think. Well, anyway, watch what we can do. Instead of writing log base 10 all the time, what we can do, since it's a common logarithm, it happens so much, we can just write log with no base at all. So all I have to do is just say log 10. So watch the calculator. If I just hit log 10, here's log, and here's 10, equals, look what it is. It's a 1, just like we said. I didn't even have to do the change of base theorem. I didn't even have to do any of this math right here. All I had to do was say that log 10 equals whatever, all right? But what is it? It's a log base 10, right? But we don't have to write it with a base. We can just write it log. So like this right here. I don't have to write log base 10 of 1,000. All I have to do is just write log of 1,000. But it's in there, isn't it? All right, like multiplying by stuff. If I said, 3, what is that? That's really 3 times 1. You don't really see it, but it's there, isn't it? What about this? What if I had square root of something? Technically, there's a little 2 there. You know how you do cube roots, 4th roots, and 5th roots, and so on? Technically, it's there, but you don't have to put it there. Why? Because you use it so much. What about common logarithms? You use common logarithms so much, it's actually programmed in the calculator. All right? And you don't even have to write the 10 there. So this is a common logarithm. It's really not that hard to work with. It actually makes it pretty easy. But if you're doing stuff and you have a log and no base on there, it doesn't mean that there's no base. It doesn't mean the base doesn't exist. It means you're in what base? You're in base 10. Exactly right. It's pretty easy. A little bit of a long explanation to talk about that, but that's what it is. So whenever you see log of anything, and they're going to do stuff, they're going to say like, what's log of 83? Right? How would you figure that out? Stick it in a calculator, right? All right, so watch. Log 83 and, oops, hit the 3. There we go. Equals 1 point, yeah, we'll say about 1.9 something. What in the world does that mean? This is what it means. Remember what that log was. Or that base, I'm sorry, is a base 10, isn't it? So what are we finding? Because people do these things. You stick stuff in your calculator and you don't really know what you're doing. Well, what are you really doing? You're going 10 to the 1.9 power equals what? 83. That kind of makes sense, because what's 1.9 really close to? It's 2, right? So what's 10 to the second? It's 100. This is a little bit less than 2, right? So 10 to the 1.9 is going to be a little less than 100. Does that make sense? All right, and that's what it is. Now, could you do this, figure out what that is without a calculator? No, not some of these crazy numbers. Only if you could write this thing as a base 10 could you figure that out, okay? But I want you to understand what you're really doing here. Does that make sense? Here we go. Just watch. I know the bell rang, but let's watch how to do this. Watch. Here's another logarithm, another base. It's log base e. Remember what e was? We talked about that. It's 2.718. We had a long lecture on that, and it keeps on going like this. Log base e. Sit down for just a second. Just a second. I know you're in a hurry, but you can wait. Watch. Log base e is the same thing as ln. Whenever you see on that calculator an ln, that means that right there. You're absolutely right. It's called the natural log. Okay? There it is. ln is the same as log base e. What is e? E is 2.718. All right, I'll give you a worksheet, then you can go.